All right, so let's begin. Today we're going to we learned till now how to calculate stress, strain, deformation, change in length for um, for a one-dimensional force acting on a body perpendicular to a plane. Okay, today we're going to learn about three-dimensional. Okay, so in that we'll be learning what is volumetric strain. All right, so now this is a one-dimensional stress where load is acting only on this surface. That is the cross-sectional surface of the load. Two-dimensional stress, you have a body like this, similar to this, but you'll have another force in the direction perpendicular to the first force. So you have the stress in this direction as well as stress in the opposite direction. So I'm going to take this as X and this as Y. Now take a three-dimensional system. You have the X-axis, Y-axis, Z-axis. All right. So there is force acting on the X-axis. There is force acting on the Y-axis, along the Y-axis, and there is force acting on along the Z-axis. So there is stress induced in this plane, which is sigma 1, and then this plane, that is ZX plane, and then you have on this plane, okay, which is nothing but Z Y. Did you guys understand the difference between one-dimensional, two-dimensional, and three-dimensional stress system?
Yes, ma'am.
Yeah, good. Now, let's proceed. There's something called the Poisson's ratio. Okay, when this comes into picture, let's look at this. I have termed lateral strain by longitudinal strain. Okay, is equal to 1 by m. Poisson's ratio mu can also be written as 1 by m. What is lateral strain? Okay, now see this particular block. You have the length L, breadth B, and depth D. Okay, you have load P on this direction, that is x-axis. You have a load on the x-axis. Okay, so it's acting, the load is acting on this plane. All right, so what will be the area of cross section? B multiplied by T. Okay, now when the load is acting on the x-axis, what will happen? Which dimension is going to change? Is the length going to increase or decrease? Can you guys respond?
Increase.
The length is going to increase. Okay, but at the same time, the breadth and the depth will decrease. Okay, if it's a pulling force, length will increase, breadth and depth will decrease. But if it's a compressive force, length will decrease and breadth and depth will increase. Are you guys clear about this? Okay, so when length is increasing, that is called as longitudinal strain. When length is increasing, how do you calculate strain? Change in length by original length. Clear? Okay, what is lateral strain? Change in breadth by original breadth, change in depth by original depth. Okay, so I want you all to please write down the definition of lateral strain and longitudinal strain. So can you please write it down? I will dictate it. Okay, right, longitudinal strain, when a body is subjected to axial tensile load. So what do you mean by axial tensile load? In the middle, on the x direction, you're applying load. Okay, when a body is subjected to axial tensile load, there is increase in length. Can you guys switch on your video so that I can see whether you're right or not? Or you can just respond to me. When body is subjected to axial tensile load, there is increase in length. Done? When body is subjected to axial tensile load, there is increase in length. Comma. At the same time, there is decrease in other dimensions. At the same time, there is decrease in other dimensions of the body at right angles to the action of the force applied. At right angles to the action of the force applied. Done? So this is called longitudinal strain. So what does the definition say? When a body is subject to tensile load, there is increase in length. At the same time, there is decrease in other dimensions of the body at right angles, okay, at right angles to the action of the force applied. So this is right angle to this, and this is also right angle to this. Okay, this is in the Z direction, D is in the Y direction. Got it? What is lateral strain? Can you write down? So you can write down this formula. Delta L by L is longitudinal strain. What is lateral strain? Can I dictate?
Yes, ma'am.
Yeah. Strain at right angles. The strain at right angles in the line of action of the force applied is called lateral strain. The strain at right angles to the line, the strain at right angles to the line of action of force to the line of action of force applied is called lateral strain. So you can write the equation delta B by B or delta D by D. So if it's a cylindrical rod, longitudinal strain is on the length and lateral strain is on the diameter. Okay? You guys are done? Only Partha his video is on. What happened to the rest? Okay, Anthony is switched on. Nathaniel is on. Tirumalai is on. Ajay, Abhikash is on. Subhashra, Astil, Prashant. Good, good. One by one, everybody. Okay, Tarun, Richin, David is also on. Thanks, guys. Rest of you, please switch on. I'll continue with the class. So, did you guys understand this? So what is volumetric? So Poisson's ratio is nothing but, why is this not moving? Yeah, Poisson's ratio is nothing but lateral strain by longitudinal strain. So please write this down. Mu is equal to lateral strain by longitudinal strain equal to 1 by m. All right. So volumetric strain is for an rectangular bar subjected to an axial load of P in the direction of its length. Okay. So volumetric strain. How do you calculate that? Change in volume by original volume. So you know this. Okay. So EV is delta V by V. In other terms, okay, listen everyone, just stop writing, listen to me. Lateral strain can be written as mu into longitudinal strain. Okay, I hope all of you know that. Lateral strain can be written as mu into longitudinal strain. So if longitudinal strain is positive, lateral strain will be negative. I hope you're following me. This is a very important step. Okay, so it's simple. So lateral strain equal to minus important. Okay, mu multiplied by longitudinal strain. Clear? Okay, so EV, how do you calculate the volumetric strain? Is so you have to include all the strain in all the three directions. Okay, so what will happen? Length will increase. There is only one load. Okay, length will increase in one. There's only one load in one direction. So length is going to increase, B will decrease, and D also will decrease. So you have one longitudinal strain and two lateral strains. So it will be minus 2 into mu longitudinal strain. So how do you write that in equation? Delta L by L minus delta B by B minus delta D by D. Got it? Clear? Okay, this step I will explain to you a little later. Don't worry about it. Clear about this? Can you write this down? EV is equal to change in volume by original volume. Delta V by V, lateral strain equal to minus mu longitudinal strain. EV, write this also, and this step. This step don't write, I will tell you later. Don't worry about it. Guys, you're done? Can I proceed? Aditya? Prashant? Are you guys done? You can just show me a thumbs up. It's done. Yeah. Okay. Prashant, you raised your hand by mistake.
Yes, ma'am.
Yeah. Tell me. Okay, by mistake. Can I proceed?
Yes,
Yeah.
ma'am.
Okay. All right. So now Use the same principle when there are two more loads acting in the y direction and the z direction. So if you see this, please pay attention. You have a block. You've got the x, y, and z directions. There are forces acting on x direction. There is a force, another force, y direction, another force, z direction. Okay, so how will you calculate the volumetric strain in this case? So for the x direction, we already calculated, and that is nothing but delta L by L minus delta B by B minus delta D by D. Okay, so we know that volumetric strain is delta V by V. Okay, so what is the change in dimension in del dx? It's going to be dx by, so strain in x direction is going to be Ex. Strain in y direction, let's take it as Ey. And strain in z direction, let's take it as Ez. So dy by y, dz by z, dx by x. Are you guys clear till here? Okay, I'm going to take strain in x direction as Ex. Now, there will be strain in x direction. I told you when there is a load in P, what is happening to L? L is increasing. But because of the load in y direction, what will happen to L? L will decrease. Guys, are you getting my point? I just hope we were in class, but are you able to understand? If there is force in y direction, what will happen to the length L?
Decrease, ma'am.
Degrees,
Decrease.
ma'am.
Yes, Anthony?
Degrees, ma'am.
Decrease. You guys are clear with that. If there is force in z direction, again, what will happen to L?
Decrease it.
It will again decrease. Got it? So what is the strain in x direction? First length is increasing, and then there is decreasing. Clear? Okay. So how do you? So Ex is, all right, Ex is strain in x direction, Ey is strain in y direction, Ez is strain in z direction. So Ex, what will happen to length? Length is going to increase and then decrease. What will happen to Ey? In Ey direction, this is the main length. Okay, it's B. So B is going to increase because of y force, but because of x force, it will decrease. Because of z, it will again decrease. Got it? And in the strain in z direction, so z direction is this. So the depth is going to increase because of the load z, but because of the load x and y, the depth is going to decrease. Okay, so now you have understood what is Ex, Ey, and Ez. So what will be the volumetric strain? Ex plus Ey plus Ez. Okay, so now if you consider sigma x, sigma y, and sigma z as tensile stress, E as Young's modulus, mu as Poisson's ratio. All right. So how will you write Ex? Tensile strain along x direction. Can you write strain as stress by Young's modulus? Because E is equal to stress by strain. Strain is equal to stress by Young's modulus. Okay. Can you please unmute and tell me if you're able to understand? E
Yes, ma'am.
sigma x by E. Got it? Okay. So in the previous slide, we wrote it as dl by L directly. Okay. Basically, we are calculating the longitudinal strain here. But we can also write it as sigma x by E, stress in x direction because of load x by E. Minus, how did this come? Mu into sigma y by E minus mu into sigma z by E. We have learned mu is equal to lateral by longitudinal. Got it? So what is lateral strain? Mu into longitudinal. What is longitudinal? Is nothing but mu into sigma strain in y direction. How can you write? How can you again expand strain? Sigma y by E. Did you get this? Any response?
Yes, ma'am.
Got it? So I can write minus, why minus? Because in the other direction it's going to
Decrease.
decrease. Yeah. Okay, so mu into sigma y by E, mu into sigma z by E. So you will get this. I hope you're able to follow. Similarly, for EY, sigma y by E minus mu, instead of y, it's going to be x. Instead of z, it's going to be z only. Okay, so in leave y, the rest is z. Similarly, Ez is equal to sigma z by E minus mu, they are just taking it common, sigma x plus sigma y by E. Clear? So now add these three, you will get this. Okay, and finally this is the equation, which you don't no need to actually remember all this. In the problem statement, what we're going to do is we're going to first find Ex, Ey and Ez, and then substitute it here. Volume will be given. They will ask you what is the change in volume. You have to find that. Okay, can you write this down, guys? Then we'll solve a problem. Done? Finished, guys? You need some more time? Kristen, Sam, Aditya. Tom, guys, what happened? Are you guys there? Finished, huh, Abhikash? Okay, so let's solve the next problem. So you can just write this. Okay, this is the final answer. Okay, so now let's go to our problem statement. This is our problem. A metallic bar 300 mm, 100 mm, 40 mm is subjected to a force of 5 kilonewton tensile, 4 kilonewton, 6 kilonewton tensile, 4 kilonewton tensile along x, y, and z directions respectively. Determine the change in the volume of the block. E equal to 2 into 10 to the power of 5 Newton per mm square, Poisson's ratio. Okay, so volume you can easily calculate 300 mm multiplied by 100 multiplied by 40. Okay, so this is the volume, it's in mm. All the kilonewtons we are converting into newtons because E is in Newton. So all the loads in X, Y, and Z direction convert this into Newton. Young's modulus is given, Poisson's ratio is given. So what's the formula? dV by V equal to 1 by E. So E you already have. Sigma X, sigma Y, and sigma Z you should find out. Mu is already there. So what is sigma X? Stress. So that is P by cross-sectional area. Correct? So load in X direction is 5,000. And cross-sectional area will be, see, X direction. So the other two, Y into Z. What is Y? Load in Y direction is 6. Okay, Y direction. Y is 100 and Z is 40. 100 into 40. Similarly, load in Y direction, so X into Z by X into Z. So apart from Y, take the other two. Okay, so don't get confused. 300 into 40. Similarly, sigma Z. Substitute all these values, you will get the answer. Can you solve? Guys, did you understand? Simple. Pretty simple. Okay. The only thing, next problem when we do, we'll take a compressive load. So if you have a compressive load, what will you do? If Y is compressive, for example, if this Y is compressive, then you just have to add a minus here. Okay, for now, don't bother about it. Just solve this problem and then I can explain the next one. You can do it as homework. Please solve.
Excuse me, ma'am.
Yes, Joel.
Ma'am, should we convert into meters, ma'am? It's in millimeters, ma'am. All the,
What is given in meters?
no, ma'am. Everything is in Newton per millimeter square, no, ma'am. Should we convert into
No need to
meters, ma'am?
convert. No need, no need.
Okay.
Why do we convert? Because all the units should be same. Okay? If in the question all the units are same, there is no need to convert anything. Okay?
Sure.
Ma'am,
Yeah.
5.647 millimeter cube.
Answer. Perfect. Excellent. That's the answer. Who answered actually? Hey, who gave the answer?
Ma'am, me.
Kristen. Okay, okay, okay. Great job.
Thank you, ma'am.
The others can also solve. I'll give you 5 minutes. At 9, I'll take attendance meanwhile. All right, answer your attendance, Alan. Subhashram,
Present, ma'am.
Christian,
Ma'am.
Tom, Anthony, David
Present,
down.
ma'am. Present, ma'am.
David
Nine
down.
and
Okay.
ma'am.
Brian.
David present, ma'am.
Ma'am, roll number 1%, ma'am.
Okay,
Seven
present.
present, ma'am.
Okay,
Five
good.
present, ma'am.
Okay. Astil. Astil. Ebbins.
Present, ma'am.
Astil is not there. Prashant.
Present, ma'am.
Mukesh.
Ma'am, he's
Present,
in
ma'am.
mute, but he's not responding.
Okay.
Asked him.
Okay. Apikash.
Present, ma'am.
Arun.
Present, ma'am.
Sam.
Present, ma'am.
Siol.
Present, ma'am.
Jason. Jason. Kristen is there. Febin.
Yes, ma'am.
Mohammed.
Present, ma'am.
Alex.
Present, ma'am.
Sam.
Present, ma'am.
Deepak.
Present, ma'am.
Sushil.
Present, ma'am.
Joel.
Present, ma'am.
Richard. Richard. Gibson.
Present, ma'am.
Mithun.
Ma'am, present, ma'am.
Gibson Sam.
Present, ma'am.
Aditya.
Present, ma'am.
So Richard is absent.
Ma'am, Richard wrote type box. Yes.
Okay, okay, thank you. And Jason did not respond. Astel also did not respond.
Ma'am, still present, ma'am.
Still is present.
Ma'am,
Okay.
Jason present, ma'am.
Where were you? The rest of you have not registered till now.
Ma'am, my name is not visible, ma'am.
You no, not there.
I paid the fees on July 8.
It should come. Can you please check with Mohan Sundaram sir?
I got the mail like I have been registered.
But your
Mentor,
name is.
Ma'am,
mentor called
ma'am,
me.
same for me as well. It's the same for me as well. I just got my number as well, but like it's not there in the system yet.
Did you find ask Mohan Sundaram sir?
Yeah, he's like they already gave like he already gave me the number. I think the same for Rohit as well. Like we have the number with us.
Rohit is also new joinee.
No, ma'am.
Can you because see Mohan Sundaram sir, see you got the number, that is fine. The number gets you get the number as soon as you join the college. But coming to EduSer, why it's not coming to EduSer? Please talk to your mentors, okay, and talk to Mohan Sundaram sir about it. That it's still not come. Wait, let me check. If I didn't call out your name, that means it's not there. So if the only reason it doesn't come is if you've not registered, why you will not register is because you've not paid the fees. That is the only reason. So if these are met, then I don't understand why it should not.
Ma'am, everything is done, ma'am.
Then please see only 28 students are there. Hey Aditya, yours has come. How come I didn't call out your name?
Yeah.
Wait, let me see. What about Rohit? Rohit is also there. Rohit, yours is also there. I didn't call out your name, Rohit.
Yes, ma'am.
Wait. I marked the attendance. Let me check.
It's showing class attendance percentage is 100%.
Wait. Richin. Oh, that's strange. I had only 20 students' name when I called out. But your names are there. Next class, please remind me, okay? Let me check what is happening.
Yes, ma'am.
Aditya, Gibson, Mithun. Mithun's name I called. Gibson Sam, Gibson Sujit, Richard. Anyway, everybody's put present only. Okay, I'll check. It's coming. Your names are coming. It's there. I don't know why it didn't come for mine. Anyways, so you guys are done with the problem. Did you get the answer?
Yes, ma'am.
Okay, so now this is the homework problem that you'll be doing. If you notice, the only change here is 4 meganewton is compressive force. And here it's given Newton per mm square. Everything else is in mm. So please convert this kilonewton into Newton into 10 power 3, meganewton into Newton 10 power 6. Okay, and then the procedure remains the same. So x-axis is 250. This is y. Okay, and this is z. So you can easily solve the problem. Okay, take a screenshot. I will upload an assignment today. Okay, and submit it by Monday. Can you do it? Take a screenshot of your notebook and submit it off. All right, so with this, we complete today's class. I hope you have no doubts. Any doubts? What is Poisson's ratio? Lateral strain by longitudinal strain. What is longitudinal strain? What is lateral strain? How to calculate volumetric strain, change in
Can
volume?
can you go to the last before slide, ma'am?
Yeah. Okay, for this problem,
Before this.
before this, okay. Here minus will come, okay? That will be the only change. Got it? For the assignment problem.
Thank you.
Okay. All right. So thank you for joining in, and I'll see you guys on Monday.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you, ma'am.
Bye.